Okay, hello. Good evening, everyone. Today, we from Padepokan 6 will present about about what happens if we bring the sun to Earth. Okay. Yeah, in this session, we have an awesome speaker. Yeah. The first speaker is Rima Odelia from SMK PGRI 13 Surabaya, and second is Reza Ardiansyah from SMK Negeri 1 Surabaya, and then also Naufal Respaty from SMK Negeri 1 Sanden, and then Rifki Ardiansyah from SMK Negeri 1 Tanjung Selor, and last is Ridzkiansyah from SMK Negeri 2 Tanjung Selor. Okay. Then next we will start our session about what happened if we bring the sun to Earth. And we will start from the first speaker. The first speaker is Rima Odelia. The screen is yours. Hello, Rima Odelia. Hello, Rima. Can you hear my voice? Yeah, I think Rima is not yet here yet. I think we can go just the next part about the next speaker. The next speaker is to Reza. Reza, screen is yours. You can present your presentation.
Okay, thank you. First, let me share my screen. Okay. Hello everyone, my name is Reza Adriansyah and I'm from SMK Negeri 1 Surabaya, and I want to present what happens if we bring the sun to Earth. What will happen if you were to bring a tiny piece of the sun to Earth? Short answer, you die. Long answer, it depends which piece of the sun, like most of the matter in the universe. Our sun is neither solid, liquid, or gas, but plasma. Plasma is when stuff is so hot that the nuclei and electrons can separate and flow around freely, which creates a goo with substance. So you can imagine our sun as an extremely big spherical ocean of very hot goo. The deeper you go, the denser and weirder the goo becomes. And next, structure of sun. First, first chromosphere, second photosphere, the third is radioactive zone, and the last is the core. For the chromosphere is the atmosphere of the sun, a layer of sparse gas up to 5,000 kilometers deep that's covered in a forest of plasma spikes that can be almost as big as Earth. It's pretty hot here between 6,000 and 20,000 degrees Celsius. So compared to our atmosphere at sea level, it basically is the same as bringing the vacuum of space down to Earth. The moment our sample arrives, it will immediately be crushed by Earth's atmospheric pressure and implode. Air will rush to fill the vacuum and use as much energy as 12 kilograms of TNT. Class sorry. Okay, I will continue. The moment, sorry, this creates a high pressure shockwave, which shatters glass, ruptures eardrums, and maybe some internal organs. If you are standing too close, it could kill you. Next is the photosphere. The chromosphere is the glowing surface of the sun. That is the photosphere. This produces the light we see. It's covered in a grid of a million hot spots called granules. Each of them about as big as the United States and over 5,000 degrees Celsius. These granules are the tops of convective columns, turning gas the brings the heat up from the center of the sun to its surface. It has about the same pressure as our atmosphere on Earth, so much less dense for there. Its heat support it so it won't implode. Our sphere now carries twice as much energy, as much as 25 kilograms of TNT, that this time as heat. For a distinct instant, this plasma will glow with a million times the brightness of the sun seen from Earth. The plasma has cooled to harmless gas. The next is radioactive zone. Here the plasma is about 2 million degrees Celsius and so dense and tightly packed up that it creates a sort of mist for itself. Energy in the form of photons tries to escape but has to wander of hundreds of thousands of years, bouncing endlessly for from particle to particle until it eventually finds an exit. The extreme pressure that holds the plasma tightly together is lost, and the material explodes with of a thermonuclear weapon could leave the surrounding city in the ruins in an instant. On the precise side, there would be no radioactive fallout. And the next is the core. Here in the central 1% of the star, we find a third of the sun's mass. The matter here is compressed by the weight of the entire star above it. In the center of the core, the temperature is 15 million degrees, hot enough to make helium by smashing together hydrogen, powering the sun by nuclear fission. In billions of years after the death of sun, this remains as a white dwarf. If we probe this core to Earth, it would cause a lot of chaos. The largest nuclear weapon ever detonated had the energy of 14 megatons of TNT, or a cube the size of a building. This core has the equivalent of 4,000 megatons. This is 4 billion tons of TNT, or a cube 1.3 kilometers high. If we get the core of sun in Paris, in the morning the citizens of London will see what look like a second sunrise. that gets brighter and brighter and hotter until London burns to ashes. In a radius of about 3,000 kilometers around the blast, everything will be burnt. The shockwave will travel around the Earth multiple times. Most buildings in Central Europe will be flattened. Eardrums will rupture and windows break across the continent. The explosion will be apocalyptic, possibly human human civilization ending. If human did survive, we could count on the sorry we could count on the dust blow into the atmosphere to create a small ice age. So if there is one tiny bright side, it will be that the explosion might be an effective way to control human-caused climate change for a few decades. And thank you. And maybe I give it back to Mr. Panji.
Okay, thank you, Reza, for the presentation about your opinion, yeah, in your study about what happened if we bring the sun to Earth. And from the participant, any question about Reza's presentation? Okay, if there nobody want to ask a question, I think the presentation from Reza is enough here. Thank you, Reza, for the presentation. And the next speaker is Asa. Halo, Asa.
Hello.
Okay. Screen is the screen is yours.
Okay. Can you see it?
Not yet. Wow. Okay. The screen is
Okay. Thank you to Mr. Panji. Uh, what will happen if we brought the sun to Earth? All right. Before I answer the question, let me introduce myself. Uh, my name is Asana Respaty. You can call me Asa. I'm come from the city of Jakarta. Right. Answer is you will die. However, depending on the size of the sun piece, like most, what would happen if you broke a small a sorry. Okay, thank you to Mr. Andi. Like most matter in the universe, the sun is not a solid liquid or gas, but a plasma. This plasma is a very hot object that nucleus and electron can separate and move freely, which can produce a substance that sticks. So just imagine that the sun is like a big round ocean made of very hot sticky substance. The deeper layer of the sun core, the denser and where the gooey substance is. What? Okay, next sample that I will explain to all of you. For example, chromosphere. The chromosphere is the atmosphere of the sun, a thin layer of gas 5,000 kilometers deep. which is enveloped by various sticky plasmas, which can be nearly as large as Earth. It's very hot here, between 6,000 and 20,000 degrees Celsius. But if we bring some of it down to Earth, it would be always west. The chromosphere is more than a million times less dense than air, so compared to our atmosphere at sea level, it's basically like bringing an empty space to Earth. The moment the sample arrived, it was immediately crushed by the Earth's atmospheric pressure and exploded inside. The air will move to fill the void and use as much energy as 12 kilograms of TNT. This creates a high-pressure shock wave which can crack glass, rupture the eardrum, and possibly some of the internal organs. The second sample is photosphere. The photosphere is below the chromosphere. The surface glows from the sun, which is where is produced the light we see. The photosphere is enveloped in a network of millions of hot spots called granules. Each of them almost as large as the United States and and with a temperature of over 5,000 degrees Celsius. These granules are the tops of convective columns, churning out gases that carry heat from the center of the sun to its surface. This sample has the same pressure as the Earth's atmosphere, even though it is denser than air. Heat helps keep it from exploding. For dazzling moment, this plasma will shine millions of times the light of the sun visible on Earth. The third sample, the radiation zone. Here the plasma is about 2 million degrees Celsius, so then dense, dense and tightly packed that it creates a sort of maze for itself. Energy in the form of photon tries to get out, but must travel around hundreds of years, bouncing endlessly from particle to particle until it finally escapes. The last sample is core. Here at the center of this star, we find one-third of the sun mass. The matter, the matter here is compressed by the weight of all the stars above it. At the center of the core is 15 million degrees, hot enough to make helium by welding hydrogen together, powering the sun through nuclear fusion. Millions of years after the sun's death, this core will still remain as a white dwarf. What if we bring this sample to Earth? If we bring a sample to Earth, it can cause a lot of hassle. The large nuclear weapon ever detonate had an energy of 14 megaton of TNT, or a cube the size of the Empire State Building. Our sample has the equivalent of 4,000 megatons. This is 4 billion tons of TNT, or a cube 1 kilometer high. To give you a sense of how big a cube is in Manhattan, once the ball reaches Earth, this extremely dense matter expands instantly and creates an explosion within a radius of about 13 kilometers. Around the explosion, everything will burn. The shock wave will circle the Earth many times. Many buildings will be flattened, eardrum will be started, and glass will be cracked all over the continent. This explosion will be apocalyptic. It may even end human civilization. If humans survive, we can hope that dust flying into the atmosphere will create a mini ice age. So even if there is a small upside, this explosion is an effective way to artificially control climate change over the next decade. While this is a good thing, I can conclude that we should not try to bring the sun to earth. Okay, thank you. Then I'll return to the Mr. Panji.
Okay, thank you Asama for the presentation. And anybody want a question about Asa presentation? If no one else want to ask a question to Asa, we can go to the next speaker. Thank you Asa for the presentation. And the next speaker is
Okay,
Ridzkiansyah.
good evening, everyone. Meeting again with me, Andi Wardana. I am your
Ridzkiansyah,
Next meeting.
are you ready?
Okay.
Okay.
I
Okay.
kill my
Especially all
Okay, this screen is yours.
screen. Okay. Uh, uh, good evening, everyone. Uh, Today I am present. My presentation is what happens if we bring the sun to the earth. Talk, Talking about the sun, you define definitely want to know what the sun is and what happens if we bring the sun to earth. Follow me and see the universe. Sun. Sun is the center of the solar system. The sun is a star that is close to the earth. Like other stars, the sun is a hot object composite of porous high pressure gas. The sun is gigantic when compared to even the large planet. The diameter of the sun is 100 times that of the earth, which is 1 4 million kilometer. Although the sun is gas is way more than 300,000 times that of earth. Temperature from the sun. Temperature from the sun. The surface temperature of the sun is 6,000 degrees Celsius, which which is emit into outer space to reach the Earth's surface, while the core temperature is 5 to 20 million degrees Celsius. The sun emits enormous energy in the form of electromagnetic waves. These electromagnetic waves are visible like wave, X-ray, gamma rays, ultraviolet rays, infrared rays, and microwaves. Sun arrangement. First is the core of the sun. Second is radiative zone. Third is photosphere, and four is chromosphere. If you already understand about the sun, now get to the point. Let's bring some sample to our lab. Yeah. The chromosphere. The first sample, the chromosphere, is the sun atmosphere. 5 5,000 kilometers deep goes the south layer of outer space, which is enveloped enveloped by a variety of spiky plasma that can be almost as range as the Earth. It's very hot here, between 6,000 and 20,000 degrees Celsius. But if we bring some of it down to Earth, will be what chromosphere. In the area where we sampled, the chromosphere is more than a million times less than ISO compared from our chromos atmosphere at sea level. Basically, it's like bringing a vacuum to Earth. What happened when the sample reach Earth? The sample will be crushed by the pressure of the Earth atmosphere and exploded into the air. Will move to fill the fluid and use energy of uh, 12 kilogram TNT. Chromosphere. This creates a high pressure shock wave then that can shatter glass, rupture the eardrum, and possibly some internal organ. So trouble is it? Of course, especially if you stand too close to the wave, it will kill you. So it's best to keep your distance. Let's go to the second sample. The sudah apa tadi? The photosphere. The photosphere is the sun rise where it produces the light. We see the photosphere. It's covered with a network of millions of hot spot called granula, which are nearly as large country and temperature over 500,000 degrees Celsius. So the granula are the apex of the convective column to stir up the gas that carry heat from the center of the sun to its surface. This sample has the same pressure as the Earth's atmosphere, although it is less dense than air. That the heat helps it keep from exploding or ball. No carry twist the energy as much as the 25 kilogram of TNT. But this time as heat, the plasma will shine million of times the visible light of the sun on Earth and will burn or light, but a few milliseconds is all that fire will be left. The plasma has cooled and become harmless. Let's go to the third sample, radiative zone. Here, the plasma is about 2 million degrees Celsius. It is so dense and tightly packed that it creates a kind of maze for itself. Wow, interesting is it? What if you bring into the lab? Upon arrival at the lab, the extreme pressure that held the plasma tight together was dissipated and the material exploded with the force equivalent of the thermonuclear weapon. Our lab and the surrounding town would be destroyed in an instant, but on the bright side, there will be radioactive outpouring. Let's go to the fourth and the last samples. The core. The core is core of sun which is free. It's a it's free very hot and its core the temperature is 5 uh 15 million degrees. Wow, it's very interesting, right? Wow, very interesting, right? What going on If the sun die, the sun will be white dwarf star sample of the core equivalent to 4,000 megatons. This is 4 billion tons of TNT, or the equivalent of a cube 1.5 kilometer high. After this dense, dense matter come to Earth, it will cause an explosion with the power of the sun, where the explosion get brighter and hotter until one city is burned to ashes within a radius of about 300 kilometers around the explosion. Everything will be everything will burn. Shockwave will circle to Earth many times, building will flatten, eardrum will shatter, and glass crack across continents, and might even enable annihilate human. Conclusion. Conclusion. We better hot try it, or we, along with humanity and the world, will crumble to dust. Thank you. I apologize if there any wrong word because my English is not very good. Uh,
Okay, thank you, Ridzkiansyah, for the presentation about what happened if we bring the sun to Earth. And we can go to the next speaker. Okay, we can go to next participant. We can go to next speaker. The next speaker is Rifki Adriansyah. Are you ready? Hello, Rifki Adriansyah. Are you ready?
Yeah, I'm ready.
Okay, screen is yours.
Bentar. Buka WA dulu. Kiri, buka download dulu. Wait. Sebentar saya buka filenya dulu ya, Kak. Di WhatsApp. Ya.
Hello, Rifki.
Ya. Sebentar saya bagi uh, lanjutkan. Ya, Assalamualaikum warahmatullahi wabarakatuh. I want to present what happen if we broke the sun of the earth by Rifki Adriansyah ini. Definition of the sun. The sun is a star that is closest to the earth. Like other stars, the sun is a hot object composed of various high pressure gases. The sun is gigantic when compared to even the largest planet. How hot is the sun? The surface temperature of the sun is 6,000 degrees Celsius, which is emitted into outer space to reach the Earth's surface, while the core temperature is 15 to 20 million degrees Celsius. How far is the sun from the Earth? Earth Earth's distance from the sun can can range from about 147 million to 152 million kilometers. The part of the sun, the parts of the sun. The sun consists of four layers, namely the solar core, photosphere, chromosphere, and corona. Solar core. The core of the sun is the part of the sun which has a temperature of about 15 million degrees Celsius. This very high temperature and pressure allows the splitting of the atoms into electrons, protons, and neutrons. Uncharged neutrons will leave the core to the outside of the sun. Photosphere. The photosphere is the layer of the sun that we see every day. It's very bright, like beats the outermost layer of the sun, namely the corona, so that the rays from the corona are not visible to our eyes. Chromosphere. The chromosphere is the tiniest layer in the sun's atmosphere. This layer is located about the photosphere and has a depth of about 20,000 kilometers. The name chromosphere comes from the fact that it has a reddish color. Corona. The corona is the outermost part of the sun's atmosphere. Normally, the corona is hidden by the bright light from the sun's surface. This makes the corona difficult to see without the, the use of special tools. However, the corona can be seen during a total solar eclipse. What what happened if we broke the sun of the earth? Of course, you can because the temperature of the sun is too hot, so that it can cause the entire content of the earth in its inhabitants to burn to the ground. This is because the core temperature of the sun is around 50 million degrees Celsius, and its surface has a temperature of around 60 60,000 degrees Celsius. What would happen if the sun did not shine off the earth? If the sun does not shine for a day, the process photosynthesis will stop. Plants cannot produce anything that human and animal needs. Thank you.
Okay. Thank you, Rifki, for the presentation about what happened if we bring the sun to Earth. And the next participant is Rima. Rima, hello. Are you ready?
Yeah. Cosmos is where
Sorry, Rima. Your sound is lagging. Hello, Rima. Plasma is where an object is very hard. The cells and interconnect can move freely, which result in the substance sticking. The plasma sample is the atmosphere of the sun, a thin layer of gas 500 kilometers deep. So the sun's heat can reach around 620 degrees Celsius. What if we bring some to the earth? This will be full.
So compared to our atmosphere at sea level is basically like firing a vacuum in the earth where the sample always immediately pushed by the pressure of the earth atmosphere and exploded into the air will move the film, the void and push up to 12 kilograms of TNT energy. This creates a high pressure shock wave that can crack the glass, shatter the earth, and possible of some of the internal organs as well. Uh, on the glowing surface of the sun, which projects the light we see, the photosphere is covered in yellow. Millions of hot spots carried granules edge of them nearly 500 degrees Celsius. These granules are the tops convective columns, strings of gases that carry heat from the center of the sun to its surface, although it is less dense than Earth. Its heat helps is not visible. The sun's surface carries twice the energy, as much as 25 kilograms of TNT, but this time as head for a blinding moments. This plasma will shine millions of times the lights of the sun that appears on Earth. Okay, thank you.
Okay, thank you, Rima, for the presentation. And I think Rima is the last speaker, yeah. And I will end this meeting. Thank you for for all the speaker to present the presentation about what happened if bring the sun to the earth. And good night.